So welcome everyone once again. My name is Olu, and this free webinar is courtesy of StarStack Solution. It's an IT training company and also providing IT services in web design, web applications, mobile apps, as well as API systems as well too. So let us kick off. Today we're going to be covering our free webinar on SQL, which is SQL. And the full meaning of SQL is standard query language. So SQL basically is used in managing our database systems. Our database are very, very essential because that is pretty much where every data you operate online on a company is placed in. It's all placed in a database. And one of the most popular databases are our relational database systems. And so why are these called relational database systems? They are called relational database systems because we have the databases being able to have lots of tables that can communicate with each other using concepts that we call primary and foreign key relationships. And there's more to it. There's also our data modeling, where you start up the architecture of your database design, seeing all of the tables that need to be built and created, what table has to depend on another table, as well as what are going to be the special constraints for these tables, what are going to be the unique keys, what are going to be the primary, and what are going to be the foreign keys. We're going to be taking a look at all of this. And then once we're done with that, we're also going to take a snapshot look at writing a few SQL queries to see exactly how we manipulate and change data within relational database systems. So we're going to start off by talking about what data analytics is. Now, why is data analytics important, and what does it have to do in connection with our databases? Well, within the database spectrum, you can easily become a SQL developer or SQL database administrator, which is very okay. However, in modern times and modern days, we have our data analyst, right? And we have a lot of data analyst positions open when it comes to data analysis or data analytics, as well as being a data analyst in these two different broad areas. The SQL is the number one most sought after skill. And so that is why it's very important. And that is what connects it to data analytics, because within the data analytics field, SQL is very, very important when it comes to data management and data manipulation. So those are very, very key important notes to always remember, and they all connect to data analytics. Now, there are some other key areas within the data analytics field, such as Python for performing more data manipulation and analysis of our data. There is our Python libraries, such as NumPy, Pandas, Matplotlib, and Seaborn, which are used for also performing other further data analysis operations, as well as data manipulation and data visualization. And then we have all other processes within the data analytics field, such as our original visualization that can be done using Power BI. And within Power BI, you can use it on different platforms, such as your Power BI desktop and your Power BI service. The Power BI desktop is basically an application you download on your operating system to utilize. And then the Power BI service is a cloud version of being able to utilize Power BI and other integrated tools and applications that work alongside that Power BI in the cloud. So let us first look at what data analytics is. So over here, I'm going to walk us through a little bit of introduction into data analytics. And then from there, we're going to jump into structured query language, which is SQL. And this is just one of the very learning guides I use for students who come in for a full data analytics or a data analyst career field training, which is very, very, very practical, as you're going to see very shortly. You're going to see us looking at different SQL queries. We're going to be using Azure Data Studio, which is basically an application for accessing our database systems. Now, it's very, very important to note that databases sit behind what we call a database engine. In this case, the provider or company's database we're using is called Microsoft, and the specific product itself is called SQL Server. So that makes it Microsoft SQL Server. Now, that is the back-end server engine that databases sit on. The actual application I'm using right now is called an Azure Data Studio. We also do have another option called SQL Server Management Studio as well. I prefer to use the Azure Data Studio just because it has access to on-premise and cloud databases. Now, what does this mean, right? On-premise and cloud. Well, on-premise means our physical databases. When you're working with a company, if they're not dealing with a third-party cloud provider, they are probably hosting their servers physically, which is called an on-premise database server. And so Azure Data Studio gives us the ability to manage our physical servers as well as our cloud servers. You can see right now through this Azure Data Studio, I'm connected to both my on-premise servers and my cloud servers. So my physical and cloud server. And as you can see over here, the cloud server I'm using is Microsoft Azure, and I'm connected to that through this very application. And it's a more modern and simple version of utilizing our databases as well as the server engines behind our databases. So we're going to be taking a look at some of these very fantastic SQL queries. This is a very long list of queries. It's part of what I use in training my students so that they have a very, very practical hands-on approach towards understanding what it is to utilize SQL, how SQL is used, how you can write what we call data manipulation languages as well as data definition languages. So we're going to be taking a look at all of this fancy stuff. As you can see, it is a lot of queries. Typically, when students go through this part of SQL, they pretty much cover everything SQL you can ever try to face or imagine in a real work scenario. So let's jump right back into our guide, or rather our learning guide. Now, before we do that, I want to first show us typically what it looks like to be a data analyst, right? Because we're talking about SQL and we're talking about it within the larger scope of what it is to become a data analyst and what data analytics is all about. So I'm going to go over here. I do have my existing website. So if you're familiar with my website, scarstacksolution.com, you can easily always visit that website. I'm going to quickly drop it also too in the chat for those of us in the room over here. Awesome. And I'm also going to drop my personal contact as well for those who might want to reach out to me later on. So you can call me, you can message me, you can send me a direct message on WhatsApp as well. Very, very effective. I'll be able to reach out to you right back immediately. So if you're on my website, you can easily go to our IT trainings. You can scroll all the way down and you'll get there eventually, or you can easily just click the beginning of the home page that says view our IT trainings. So when you click on that, it pretty much brings you down to where the trainings are. And these are some other trainings. These are cloud trainings for Azure or AWS cloud computing for people who are eager to jump into the cloud computing career. We have our full stack software engineer, where you're basically developing web apps and being able to also deploy those web applications to the cloud or on-premise. And then as we scroll down, you're going to see there's a few other courses and trainings I do. I'm just going to give this a little bit more time to load up. So over here, we see our data analytics and SQL. And from over here, you can even click things like the Glassdoor salary confirmation to see exactly what data analysts are earning at the moment. So you can see right here from Glassdoor, data analysts, they make a significant six-figure salary income, which is very, very awesome. So you're not just learning any new field, right? You're learning a new field and you're securing the bag, right? You're making big time money. So that's why the data analytics field is very, very important. Even from here, you can see some of the top companies that are basically employing data analysts. You see Google, you see Microsoft, Intel, Amazon, and you can even see what those companies are paying right now. You can even see the amount of jobs that are just available is outstanding. 2,000 jobs from Google for data analytics, 3,000 jobs from Microsoft, about 1,000 jobs from Intel, 20,000 jobs from Amazon. It's just unbelievable the amount of opportunities that are in there. So from over here, if you head back over here, you can see some of the tools I use for my full data analytics training, which involves SQL and other areas like Python, Python libraries, Power BI for data visualization, and then we have where we talk about data warehouse, and these are all practical. You literally be creating real life projects. So you've got your data warehouse where we'll be implementing Synapse Analytics. You've got what we call the extract, transform, and load process, which is basically extracting data from one source, transforming it by changing the data or adding or rather integrating all other types of data into that current data and then loading it up to your destination, which might be just a database, it might be a data warehouse, it might be an Azure storage, which is a cloud storage service. That typically is the process for the ETL transactions, So that is what that is all about. And then we also have our Power BI, like I mentioned, of course, earlier on for data visualization, where you present useful data by utilizing the data you fetched from a database and transforming it or changing it into visualized data, which could be pie charts, bar charts, and other forms of different types of charts. So with all of that in place, looking at some of the key tools, this is a new website, a newer website for ScarStack solution, still currently under development, but I can take you around some of the key areas I cover. So we're going to jump into the data analyst field. Once this is eventually released, you can easily come to IT training. You can see all of the fields. You can click on the IT training itself. You can begin to see some of the immersive IT trainings we cover. If I go over here, I can access things such as certifications. I can look at the syllabuses. I can also look at the IT training. So let's quickly click this. When I click that, I begin to see all the different fields, right? So from here, I can easily access my data analyst to go and get more information about what exactly the data analyst IT career field is all about, and look at things like the certifications and all. But I'm going to just go through this avenue, and I'm just going to select over here. I'm going to say data analyst. So I'm going to select that from here. And so one key thing is, apart from SQL, we mentioned Python, Power BI for data visualization, our Python libraries such as NumPy, Pandas, Matplotlib. Those are used also for visualization and data analysis as well as data manipulation. And then once you get in here, you can start to find different details such as the kind of certification you can get, which is called the Fabric Analytics Engineer certification. So the training is meant to be able to have you not just start up a career as a data analyst who is very good with SQL and all of those key areas I mentioned, but also someone who is also able to actually achieve the certification should you want to pursue that as well. And so if you go down over here, it tells you exactly, gives you a quick highlight of what you would gain being a data analyst. It breaks down all of the skills for you. And it mentions SQL, Power BI, and Python. Also mentions the ETL we mentioned earlier on, and Azure Data Factory, including Synapse Analytics for data warehousing. And then we have other tools like Jupyter, Anaconda, and Visual Studio, which typically students will use in managing their environment for implementing Python and Python libraries. So very, very, very cool and interesting stuff. As you go down, you're going to see things like our syllabus. Now, this is exactly where I was heading to, right? So the syllabus is broken down into 8 key areas. Those areas involve SQL, and you can see with SQL, we're going to work with SQL itself. We're going to work with T-SQL, which is Transact SQL. That is Microsoft's way of pronouncing or describing their own version of SQL. And then we're going to look at, the main areas, which are the data manipulation language, data definition language. We're going to look at the server we're working, which is a SQL server, as well as an environment to run our SQL queries. And then you can start to see other things like data modeling. You can see Python. You can see all of the things we cover under Python for full training. You can see Python libraries that I mentioned earlier on for data manipulation and visualization, where we cover NumPy, Pandas, Matplotlib, Seaborn, and we utilize tools like Jupyter Notebook, Anaconda, as well as Visual Studio Code. We now go down to other areas like Power BI, where we cover some key aspects on that Power BI. We look at our extract, transform, load, our data warehouse, and big data. Over here are some of the tools that we utilize for full training, some of them for SQL, some of them for Python, some of them for ETL processes, big data, and data warehouse. These are just, I know they are buzzwords to some of us, but these are like the key things that you need to become a data analyst, including and most importantly, SQL. So that's pretty much about it. Our trainings typically they span a duration of 12 weeks. We have practical hands-on delivered to students every week, and those practical hands-on, they're actually scored. So you get given a grading criteria of 100% depending on how you perform. So it's pretty cool. It's just like being in school, but a more social, nicer type of school. So pretty cool stuff. And then, of course, I also have other perks for the training. So you also have your weekly practicals with grading that I just mentioned. Our classes are all pre-recorded, you understand? So you can easily jump back to any class that has been covered to say, oh, I want to see how the instructor implemented this. How did they execute that? How did they install this application? You can always go back to track our previous classes. And it's very helpful for times when you might need to miss a class. Maybe you're traveling, there's an emergency situation, you still would not miss out of that class because everything is pre-recorded. Well, everything is recorded. All our live classes are recorded. So you're able to go back to go and see if you want to go relearn something, or if you missed a class, you can easily jump back to see what was covered. And we also offer mock interview preparations to students as well too. Very, very, very important, because this is a practical class, and to fully and truly get students ready for a real life scenario as a data analyst, you need to have that confidence to be able to answer questions theoretically and practically within the data analytics field. So we have the mock interview split into two different processes, the practical and the theoretical, where you'll be asked questions for the theoretical. The practical, you'll be expected to do live assignments right in front of me so that I know you are fully ready and all set, to sort of pursue your new career in data analytics. And so we have all of those things. We also help with creating a free resume. So I'll help you create a free resume, help you build it. I go over the resumes with the students after the trainings so that they know exactly all the content of the resume, and they're able to sort of have their own personal overview of that resume, perform any necessary updates they need to do, to maybe customize or fine-tune that resume to their own specific liking. So we do that. Also offer job placement. So as you're trying to get into a data analytics field, show you how to exactly get in there, link you to recruiters, show you available jobs that you can apply to. And finally, also provide the students with an on-the-job support for 2 to 3 months, even after once you've gotten a job. So being able to support you, as you transition into that new job and, that new career, you definitely need that extra support for the first 1 to 3 months. So we're always here to sort of guide and help with that as well. And so as you go down, you can see the certification that you're going to gain from that is going to be your certified Fabric Analytics Engineer Associate degree. And the cost for the training is just about $1,200. We do have flexible payment plans as well. So if you're interested in that, definitely reach out to me through my phone number that I've shared, or you can even send an email as well. So I'm going to just put that email in the chat as well. All right, so the email has been shared, my number, and as well my website. So, so that's pretty much all about that. So with all of that in mind, let us jump into, what we have to do today. So I'm going to first cover some key things. Over here, these are some of the tools and applications utilized for the full data analytics training, but we're going to skip past this and actually quickly jump into the introduction to data analytics. Try to have a little bit of understanding about what data analytics is before we then dive into SQL. So over here, it tells us data analytics is the science of analyzing raw data to make conclusions about the information from that specific data that is derived. And it tells us that many of the techniques and processes for data analytics, they have to typically be automated in a process or an algorithm form in order to walk over that raw data that has been retrieved for human consumption. What does this mean? This basically means when we take a raw data, for example, from a database, right? We can use SQL queries to retrieve our data, which is our SQL queries. And I mentioned the word query because when you write an SQL script to retrieve data from a database, such as over here right now, if I went ahead and I ran a script here, let's take a look at one of them. So let me take a look at this one here. Let's run this. Actually, I'm going to switch into what we call different database instances, and I'm going to jump into the one that is called the master. And I'm going to go ahead and run that. So if I run this SQL query, I'm looking at information in the database, and this information itself has certain restrictions to it based on what we are seeing over here. And I'm going to walk us through some of these things, in the next few minutes. And over here, I'm retrieving this data. And so I can retrieve a data, and I can have a data that is a raw data, put it into a database to make it relational, and then write SQL queries to retrieve that data. From here, I can now manipulate this data, plug it into what we call Power BI for data visualization, and then I can visualize this data in form of a chart. I can also use Python, right, to fetch this data from my database, and then I can even implement Python libraries for more visualization purposes. I can use what we call NumPy, or rather I can use Matplotlib and Seaborn to visualize that data as well, to achieve that chart data, right? Whether in form of a pie chart, bar chart, and we have so many other different types of visualization chart. So Python libraries can also achieve data visualization for us, where we see our data transformed into a visualization detail. We can also achieve that using what we call Power BI. So pretty much that's what this is telling us over here. So we also have what we call big data. As you would have noticed when I was showing you the key areas I cover, big data is also a very important thing. The reason for this is because in data analytics and data science, there's what we call data, and then there's also what we call big data, right? So big data means you're not just talking about any regular type of data. You're talking about huge data, talking about like Netflix, right? It's a video online cloud platform, and it hosts a lot of TV documentaries, movies, TV shows, TV series, and whatnot. And all of these things occupy large spaces. We're talking about 4K resolution, high definition resolution, video deliveries. And so big data becomes something that is much more larger and bigger than just your normal data. And so that is also something I cover. If we look over here and I go down in here, you're going to see exactly me talking about big data here within our full syllabus for data analytics IT training, where we use tools and technologies such as Azure Data Lake, storage accounts, Oracle namespaces, containers and blobs, which are concepts from storage accounts, and as well as the shared access signature that is used in securing our online cloud storage environments. So let's jump back into that learning guide. And so that's the definition of data analytics, the comparison of big data with just our normal data as well. So we're going to skip through some of these things, and then we're going to come in here, the types of data analytics, right? When you're performing an analysis on data, what are the different types of data analytics? Over here, we have one that is called the descriptive analytics. This basically describes what has happened with a specific type of data over a given period of time, which means you can be looking at the data from the beginning of this year to the 6th month of the year, which is June. So typically trying to look at data from January to June to understand what has happened. How are we performing business-wise? Are we doing well? If we are not doing well, what is the data looking like? What can be done in the future to improve that? You understand? So descriptive analytics is very, very important. Now, another one I always like to mention because it's very, very popular is our predictive analytics, right? Kind of also in a way contradicting or being the very opposite of descriptive, right? You're no longer looking at past data. You are trying to use your past data to make good analysis of the future by implementing what is called predictive analysis, right? Kind of like how within the weather scenario, right? When you watch the weather, they try to predict what the weather analysis will be by using current and past data, as well as data that can enable them see the growth of the weather propelling or reducing to say, hey, this is what the weather is going to be like on this day. Oh, we have a hurricane coming, we have a bad storm coming, a tornado, etc. And so predictive analysis then looks opposite from descriptive analysis to look at how you can use current data to predict future models for an organization, a company, or even for a specific individuals. So those are two key ones to look at within the types of data analytics. As you can see, we have about 4 of them: descriptive, diagnostic, predictive, and prescriptive analysis, right? So now we're going to look at some other things, right? So we're going to look at the data analyst role. Now it tells us over here that the data analyst role is a professional, or rather a data analyst is a professional who specializes in certain aspects such as collecting, processing, as well as analyzing data to support decision making within an organization or company. And so that tells you that within the data analyst role, it's all about taking your data, having an existing data, creating a data to exist, collecting the data, taking the data through a certain type of process, either through data manipulation, data management, data analysis, and then perhaps even visualizing the data or performing what we call an extract, transform, load process, whereby you take that data, you transform it, and then put it to a final location. Think about the ETL like a person who collects different types of goods from different areas, right? Takes from one region, maybe the eastern region, the western region, the south region. It brings the products together. Now it has extracted those products. Now it wants to package those products in a way before them passing them to a specific customer or client or even a warehouse. So it starts to take one product from region A, takes another from region B, takes another from region C, opens up a box, puts all of those items in there. Now that data has been transformed, or rather in this case, the product has been transformed. When he has transformed that product, extracting them from different sources is now ready to load them to a final destination, which might be a customer, a client, or even a warehouse, right? And so it takes that transformed product and then loads it to its final destination. And that's kind of like an hallmark of what ETL process is all about. And so we see other concepts such as data cleaning, which could also be a part of data transformation. Sometimes when you're transforming data, you are in a way cleaning your data as well too. So sometimes it's not all about integrating things together, but you might want to filter items. You might take data from different sources and say, this is good, but now that I have all of these data extracted, my mode of transforming is going to clean that data. So what does that mean? I'm going to take some specific data I do not need. Maybe I want to look at all of this data and I want to filter out, maybe it's an employee's type of data. I want to say, okay, some people probably are within this data from January, but as far as June is concerned, I want to know how many employees are still with us. So I might be able to query that data to say, based on the list of employees from January to June, retrieved from our different branches all over the country that has now been extracted, I want to transform and clean that data by removing maybe employees who have retired, employees who have moved on to a different organization, or employees who are maybe relieved, maybe due to us cutting our workforce down. So that is a form of data cleaning. And you can see right below it, it comes to data transformation that we just talked about a few seconds or minutes ago. So the data analyst is expected to do those things. So you can see the very importance of mentioning data transformation, data collection, that is collecting your data from various resources or various sources, such as a database, a spreadsheet. A spreadsheet could be like a Microsoft Excel spreadsheet. I could decide to retrieve data from a spreadsheet and then load it up into an Azure storage. So we have all of these very fantastic tools at our hands as a data analyst. And ironically, majority of them stand from a source. Where do you actually get the data source? And one of the biggest data sources is our SQL or SQL relational databases. So with all this in mind, we're going to jump into other things. As you can see, the role continues to mention data analysis that we talked about, data visualization, reporting your data, and so many other things. So with that in mind, I'm going to quickly skip on to page 83. So I'm going to scroll down pretty fast over here. And so we're going to start looking at SQL. Now, it's important to know that even though we're talking about SQL today, we're most probably going to be looking at it from what I call an on-premise environment, which is we're talking about physical servers here. That is our physical SQL databases and SQL Server engines. There is, however, also the cloud version. So in terms of cloud service provider, right, we're talking about cloud computing here, right? We have different service providers such as Azure, Amazon AWS, Google Cloud Platform. So to show you a quick example of what that would look like typically within an Azure environment. So over here, we are looking at an Azure Cloud environment application right here. And within this area over here, I can see the different types of cloud computing categories, right? So typically, I cover a cloud computing training, right, for Amazon or Azure, right? So Amazon AWS and Azure. And typically for Azure students, this will be the environment they'll be working at least 80% of the time. And so in here, you can see different categories of the cloud services that are provided by these huge companies, regardless of if it's Amazon, AWS, or Microsoft Azure or Google Cloud. Majority of the functionalities you'll see, such as compute, databases, containers, storage, networking, security, they are basically consistent across these different cloud platforms. In this case, if I wanted to take a look at databases, when I click on the databases, I can see the different types of database services. I can see the cloud version of the SQL database that I'm working with over here physically. I can also look at other key areas, such as what we call a SQL managed instance, which is definitely a little bit advanced for this class. But there are other types of tools that are related to SQL and relational databases. As you can see, all of them having the word SQL, 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 and SQL. It's just everywhere. And so that is an example of what a cloud environment looks like. Now, if I go ahead to create a database in this cloud environment here, I'll be able to have the same sort of scenario I'm having over here, where I'm seeing this funny looking icon or item, which is a database. So right here, what we are looking at is a database that is called master and has a series of tables this one called address, ASP.NET role claims, and the list goes on and on. New employees, managers, JWT clients, jobs, all containing different types of information. When I drop this down, I can see other types of databases too that I have here. And so what we have as the dots, or rather after the dot sign here, are what we call schemas. And we're going to be looking at schemas as well too very, very soon. So back to our learning guide over here, let us jump into SQL and see what it is all about. Over here, we're introduced to SQL, and it tells us writing SQL queries is a fundamental skill for working with relational databases, which is true. And again, one of the key reasons for calling a database relational is the fact that you have tables that can relate with each other. Everything is interconnected within the database spectrum, so that retrieving highly complex data is very, very easy. And when you're not retrieving it, you have utilized a concept such as entity relationship model to spread out the data that is all needed, but spreading them into different tables for their own specific, unique, or individual purposes. What do I mean by that? If I come over here right now and I open up a chart over here, let's take a look at this one. If I take a look at this, I'm pretty much breaking down a huge and cumbersome data into different tables. So right now, I have all of these tables, and all of these tables are all interconnected. They are all within a database. This is an example of what we call entity relationship model, where you are able to model your tables and create a connection of foreign and primary keys based on things that we call one-to-many, many-to-many, or one-to-one relationships. All these fancy relationships I just mentioned, it just means what is the state of connecting from one table to another. In this case over here, when I zoom in a little bit, I can see that I'm connecting from a departments table to something that is called the main table here, called the employees table. I can also see it labeled yellow over here. It is therefore the main table. Now, to draft and create such a very dynamic set of tables within a database, you need to put on your architecture hat and say what data in one table will relate to another data in another table. You come to see when you jump into a full IT training that knowing what table has a primary key that will be referenced to something we call a foreign key is very important in knowing the tables to first create. By looking at this scenario, if I go ahead to first create this table, I will run into a lot of trouble. I have to first create the most least dependent table to the table that will be the most dependent. For example, it's like looking at a family where you have the father, the mother, and about 4 kids. Let's say the first kid is 30 years old, the second kid is 20 years old, the other kid is 10 years old, and the last kid is 1 year old. The least person within that family structure of 6 who is expected to have any major responsibility is, of course, the 1 year old. And so if something went wrong in the house and you wanted to hold anyone accountable, and everyone was present in the house when that thing happened, the last person you want to question would be the 1 year old kid, because they are the least person within that equation. And so a typical example is seen in this scenario. Over here, this table called the employees carries the most responsibilities. The reason is because we have something we call a primary and foreign key relationship when it comes to relational databases. This means all of this table can connect to this table to retrieve further information. And we're going to get to that part very shortly. But what exactly does this mean? This means in this case over here, I have a departments table that is accessing 2 columns. As a matter of fact, I can just go over here and query that table for you so you have an idea of what is going on. I can copy, or rather I do not even need to copy that. I can just open up a new query and I can look at my departments table over here and run a quick query on that. As you can see exactly, I'm looking at a table that has 2 columns. This is very similar to how we would take a look at an Excel sheet. Yes, I see rows, then I see columns. I see 2 columns over here, one called the department ID and one called the department name. Now, what is all of this? What does it really mean? Let's take a look at another query. I'm going to come down over here and I'm going to say select all, which means select all the columns from a specific table. This time around, the table is going to be the dbo.employees. So I'm going to go ahead and just put in employees. And then I'm going to put in a division layer over here, which is a semicolon, but separates what we call a query from another query. This does not necessarily have to have that because it's the last query. Assuming I had a third scenario of a query here, I will need to put in that semicolon. It acts as a sort of breakpoint to distinguish between one query from another. In this case, I can then choose to run this query. And when I run it, I get my 2 different results from the 2 separate tables. Over here, I see a department ID column and a department name column for the departments table that is reflected over here under a schema that is called the DBO schema. All of these tables are under a database that is simply for now called a master database. I have few other databases over here, all of them having that same icon. And so in this scenario, I can see that the employees table has way more columns than the departments table. This query here returns this level of information, which is this 2 columns. The second one over here returns all of this. There is a relationship between this table and this table. And we can validate that from different scenarios. Scenario number 1. By me taking a very concise look or specific look at these columns, I can see something that makes me suspect that there's something called a department ID over here. While this is not foolproof that this is connected to this table, because of experience, I can always tell that once names have similar meanings, there is probably a correlation of communication between those tables. A good proof will be to look at the entity relationship model, which is the diagram we're looking at over here, which shows me that this table called departments that we've just queried and this other table called employees, which we've just queried as well, are connected through a line here. That tells me that one department ID here is at least present in one or more scenarios in the employees table. In this scenario, this department over here has the right to have what we call a primary key. The primary key within a table is the key describing a column that is the level of authority within that table. It means when I select a key as a primary key, it becomes the exceptional, unique identifier for that table. It should also not be duplicated for best practices. So when you define a table, having it as a primary key, by definition of that primary key, you do not expect to have that column being duplicated. What exactly does that mean? If I go back over here and I look at the department ID here, this column is a primary key column, and you can see all the numbers are written this way. Because of the way this table was created, if I try to put in a new role here into this table and I call the department ID 8, it is going to fail. Because as a primary key, it is expecting these data to be unique. What exactly does that look like? Well, if I just go over to this departments table, and I come down up here and I right click on this, I can create a script and I can say script as create. What this would do is this would show me a scenario where I was assuming to recreate this table. And then from there, I will see all of the logic that has been implemented into that script to put in place any rules, validation, or constraints that is needed for that table. Let's go ahead to do that. I'm going to click script as create. And then I'm just going to give it a few seconds for it to pull up the information we need. This is good. So over here, when I look at this table, I can see it using the word on primary, which is a more advanced way to write a create statement for creating a table. But over here, it is referring to this department ID. Now, let me quickly show us another scenario that describes the primary key, and then from there we would see a foreign key relationship to have a more better understanding. I'm going to go ahead to click on open. So here I'm going to look at some of my queries, and I'm going to select this one here called SQL ERM script. I'm going to go ahead to open it up. Over here, I can start to see different statements that was used to create some of all of these tables. I can see the departments table being created here. This statement is used to create this table. And go ahead to close this. That is called the departments table that has this data. We can see it has two columns, department ID and department name. When I look over here, I can see those two columns being mentioned. And the top one here is called the primary key. The type of data inside it is a numeric value. And so in SQL, we call that an integer. The type of data that is passed into the department name column is a text or a string, just like anybody's name. And so that is described as a varchar. The 30 here that you're seeing is saying when someone puts in data into that department name, it must never be the character, however long it is, should not pass 30. That means I can't go ahead to give a name that is very long, that is more than 30. I will get an error when trying to insert that data into that table called the departments table. So this creates a very simple table that is called the departments. It takes note of the database. If I look at that database, that belongs under here. Takes note of the schema. A schema is used to describe the owners of different objects within a database. This is so that when you look at a whole list of tables, you have an idea of who owns what within an organization. And then finally, I'm describing the table name within the database. And this table has two columns. The department ID column for capturing unique identifiers. It's almost like looking at it like a social security number. This is the unique ID number for this new role, and then every other details can fall in place. The primary key is not always required, but it's a good best practice. And so back to our discussion over here, when I create this table eventually with that script we're just taking a look at, and I see the department ID, I can see the department name. None of these names can be more than 30 characters based on the script that has given the instruction while creating that table. Now, if I go down to the employees table, it's going to take a bit of a scroll down. I can see. Just look at the difference between the create statement for the employees, which is starting at line 254 down here, compared to the beginning guy here, which is the departments. Just two columns. Very simple, not much requirement. We come back down to line 254, and then we see a whole new paradigm of script. And that is not even that. Let's scroll down a little bit more. I think we may have skipped it, so let us scroll down a bit. Yeah, that is it right here. And so over here, when this table is described, you will see that for this table called employees and departments, for them to connect together, they are connecting through one of the columns called the department ID. The department ID is its own primary key within the departments table. However, it is the same information that is being utilized within the same employees table. But this time around is being seen as what we call a foreign key. So why all this big grammar? Why is there primary key, foreign key? Well, it is that way to say this department is in its own home or domain. Whenever it is outside its own home or domain and being utilized in a domain outside the perimeters of its own area, it will be seen as a foreign key. Kind of like how we use the word foreigners in real life. And so over here, it is seen as it is being seen as a foreign key over here. However, it is the same data that is being used. But to achieve this programmatically within the SQL world, you need to describe that while creating these tables. Or maybe even later after creating the table. Maybe you created this departments table and then this employees table was there. And at some point, you guys didn't feel there was a need to connect both. Now that you've seen a business purpose or reason to do that, you can now go back into those scripts and run what we call updates to update the script that was used to create the table so that that script now works in accordance to your business purpose. So based on that explanation, if I navigate back over here, I'm expecting to see our employees table connected with our departments table through a primary and foreign key relationship. And I need to see the proof of that here. So when I look down, I can see that word that is being used called department ID. And then it uses a word that says, this is a foreign key in the employees table. Well, where do I know where this foreign key is coming from? It means it's a primary key somewhere, but now is in my own domain, which is the employees table's domain. It is now a foreign key because you have passed it in here as one of the columns that must exist within my table. And so in this case, it is being called a foreign key, and we are using the word reference to reference its origination. Where is its original domain? Well, it's originally coming from the departments table, and even more specifically, the department ID column. And so you can see that above, we're looking at the departments table that had a column called the department ID. And because we wanted to make or establish a connection between the departments and the employee table, we have included a name here, which does not even have to be the same name as the original primary key from the departments table. What makes SQL understand what is going on is this word here. So I can call these Power Rangers if I want. It does not have to be this. The word foreign key says this is a foreign key. It is referencing the department table. That is where it is coming from. And that establishes that primary and foreign key relationship. And so as we go down, we will see other statements such as insert. Over here, what this is doing is when you create a table, it is first empty. There's no data in it. And then we run scripts that are like this to insert data into those tables. We can even perform what we call bulk inserts, which is writing a different type of script that would at once load up a whole lot of data and use less SQL queries. This is typical for organizations or business where they're trying to load up a whole lot of data, either manually or programmatically. Case in point, our ETL process we mentioned. I could use an extract load process to get data from this table here, move it, and load it into another table without doing that manually. And I can achieve that through ETL. Can extract the data from this database source. I can clean the data should I want to do that. I can even transform the data and then finally load it into another database and table. And so one key thing to note here is, given this employees and the departments table, we've mentioned that we added a column over here called the department ID that is referencing our departments table. What this means is when I put in a new value here, any value coming into the department ID must actually be an existing data from the departments table. So it has to be that data. We're not bringing in any new data. That table called employees is just referencing what is here. So if you were a new employee right now and I was putting your data into our company data, I cannot, within the insert statement of this employee's data, assign you a department ID that does not exist in the original departments table. That is another concept of foreign and primary key. That data has to have existed or currently exists in the departments table. That is why you're referencing it. It is not an angle for you to just put in random data. So when you're putting in that new value, some key things that are not foreign key reference, those things can accept new values. As you can see, it's not everything here that has that is a foreign key. This here is a foreign key. This is a foreign key. This is a foreign key. This, and this as well are all foreign keys. All other ones are free. So for those ones, I could put in a new employee's name, their last name, their age, their gender, their hire date, their salary. Then when it comes to the job ID here, as I can see over here, that is referencing another table that has its own primary key that is now being looked at as a foreign key in this table. When I put in their job ID, it has to be a job ID that exists in the jobs table. If you put in any random information inside this employees table for areas that are foreign key columns, you're going to get an error if that value or data does not exist in the original table. So in the case of the departments, let's say there was a new department that just got created by the company, maybe cloud department. or machine learning department. And now you've employed the first 3 employees, and you need to insert them into your employees table. However, they must use a department that is new and does not currently exist in the departments table, which would be a department ID 9 for the word machine learning department. So instead of that, we have technology here. So you need to come into your departments table to insert a new row here, assign it the number 9. There are ways for that to be programmatic. That means it's not every time you have to put in a department ID. As you can see over here, I have this function over here called identity one-on-one, which says whenever I put in a new employee data, I don't need to be assigning their special unique ID. Go ahead, look for the last item I assigned an employee's unique ID, and then increment it by 1. So that's why you see when I start here, I'm starting from the first name and last name. I'm not concerned about the employee's unique ID number. That is going to be programmatically inserted into my new row. So back to our department. When I go in, I can now enter a department new ID of 9, and then I can put in the department name called, for example, machine learning. So now that department ID 9 and the name machine learning now exist here, if I was going to enter information for those 3 new employees, I can then go ahead to use the department ID 9 when I'm filling in the details and I get here, and I won't get an error. Why? Because that department ID truly and actually exists within the departments table. And then finally, part of the reasons why we do all of this is so that every individual or specific type of data can stay put in their place, but can be combined to be queried whenever we need full details. What does that mean? As I'm taking a look at this table, as far as I'm just querying just that table right there, which is the employees table over here, the department detail is able to provide me is just the ID. But by joining this table called employees to our departments table, courtesy of our primary and foreign key relationship, I can see beyond just this department ID. Because even though I'm just referencing the department ID here, it lets me know when I'm looking at the employee table to know what department this employee belongs to. I can then write a query that will let me know the actual department name. Because if this was a big organization, I might not even know the department name. All I'm just seeing are IDs. So I can then go and write a query here that says, select all from employees, and I can give this an alias or a nickname, and I can call it EMP. And I'll use the clause statement called join. It's a programmatic clause. That is why you see it's being generated for us or pre-provided for us. So you join the departments table. You can even select that easily. I can call this DP. Then I need to make an established connection between the employee and the department's table. What connects them together? It is their primary and foreign key relationship. I can then go ahead to say on, and I'm going to access the column in the employees, right? That is called department ID. And I'm going to say it is equal to the department ID from the department's table, because those are the 2 establishing connections. The department ID, which is a primary key in its own home and domain, and yet a foreign key in another person's domain, which is the employees in this case. And because I'm using this alias, rather than using all this long name to establish that connection, I can use their nickname. I can then go ahead and say EMP, and then when I put in a dot, because this serves as an object, it now gives me access to all of the columns under that EMP, and EMP is literally the employees table. I can then scroll and select the department ID, that guy right here. And I can now say E is equal to match that foreign and primary key relationship. I can now give a space and then now connect it to the department's own department ID. And of course, I already have the alias there, so I can just use it. And I can just put in the dot, and then it provides me with the items under that object as well. And then I can select this guy. And now if I run that query, the select asterisk all will select everything, both the employees table and the departments table. So let's run that. So all of these are the employees tables. When I go to the end, I can see the department ID and the department name. That is coming from the department table. So the primary and foreign key is providing us with all of these great advantages. Creating accountability within our tables, ensuring we can reference data from another table using this table. As a matter of fact, if I wanted to delete some information based on the primary and foreign key, I will be warned as well to say, oh, you can't delete this or you can't delete that because there's a primary foreign key constraint. If I want, I can fetch data where the department is only in department 5 and 8. I can go ahead to say where, and then I can reference the department depending on what my business objective is. I can say as far as the employees tables are, so I can use the employees alias. And then fetch, because what I want to query or give a condition is the department ID, which is the employees department ID. Because I want to have that perspective from the employees table. I want to know all our current employees who are in department 5 and 8. I can now select the employees foreign key for our department ID. I can use the word in to include a group of items. I can open up a bracket and I can throw in the 5 and 8. And if I query that, you will see that instead of now that we have up to about 20 rows, that row would reduce because it's only now looking at some specific data. So at this point, it's returning just 5 rows of data for us. I can also say I do not want to see all of these rows. This is too much. I want to specifically just select the employee's first name, their last name, their age, and I do not even want to see their department ID. I just want to see their actual department. I can now update this that selects all of the rows. I can throw it out. And then I'm going to specifically select the rows I'm interested in. And our alias here is going to help us again. Come in there and say EMP dot first name. I'll put a comma to separate that column's objective from the other one. Say EMP dot last name. Now I've selected employee's first name and last name. I've been told to also provide the age. I'll say the EMP dot age. And then lastly, we are told to retrieve the department's name. So I can go ahead to reference our alias for our department and say DP dot the name. And so step 1, we're looking at 2 individual tables, departments and employees. We are now looking at one table that combines both of them. And then we further drilled it down to say, we want to see just a specific type of data requested by the manager or one of our stakeholders. And then we put in a where clause condition to say we only want to see employees who are in the departments 5 and 8. And then lastly, we said we don't want all of this long data. There are some specific key data we want to focus on, which is the employee's first name, last name, age, and department name. And we got across all of that data. And if I run that, I see a very clean data. And so this just goes to show you the power of SQL and how it is used to manipulate, manage, change data, as well as many other types of roles that the SQL can occupy. And so as you can see through an example over here, there are lots of complex SQL queries that can be written. See this, for example, as a requirement over here. It says create a new table having all of this. And then it says during the table creation, ensure the following: 10 very high-level things you must do to put together the create table statement. Eventually, all of that question boils down to this answer. So there are many ways you can utilize SQL. As you can see, I have a lot of scripts over here that I used to go through with my students to make sure they are very, very, very strong and inept, practically and theoretically, when it comes to SQL, as well as other areas within the data analytics field, such as Python, Python libraries, Power BI, data warehouses, big data, as well as extract, transform, and load. So with that, we'll wrap up this class, which is our free webinar on SQL practical learning. So if you have any questions, definitely feel free to unmute your mic, as well as being able to ask your questions via the chat as well. So if you have any questions, I'll be stopping the recording right now because we have the class recorded. But if you have any questions, definitely feel free to ask. I'll just wait for that for another 30 seconds to about 1 minute for people to come up with their questions while I stop our recording. Thank you very much.